Hello, I'm Anthony Lau, a technical marketing engineer at Cisco Systems. Welcome to the BNG High Availability Cluster Demo on the ASR 9000.
So starting from the left, we have my laptop here. My laptop would be generating a DHCP packet which will initiate the IPOE session. My laptop will also be the client for the video stream. Next we have the catalyst switch. The catalyst switch is just there to provide lag functionality between the ASR 9000 and my laptop. Next we have the ASR 9000 itself. Now we have two ASR 9000s that are set up in a cluster. Essentially what that means is these two routers will act as a single router. One router would be designated as Rack 0 while the other router would be designated as Rack 1. Next we see the four red links between the two routers. This is the control portion of the cluster. So these connections are connected to the RSPs of the respective routers. Only one link is needed for the cluster to remain operational, but four links are provided for redundancy. Next, we have the four blue links connected between the two ASR 9000s. These are the data links portion of the cluster. This provides the forwarding capacity between the two routers in the cluster. Later on in the demonstration, we will show you why this is necessary. Like the control links in the cluster, the data links only require one link for the cluster to remain operational. However, losing links in the data area will reduce the forwarding capacity between the two routers in the cluster. In a typical cluster configuration, you would spread the four links between multiple line cards. However, in this configuration, we only have one line card per chassis, so we will not be demonstrating a line card failover. Lastly, we have the video server, which will be providing the video feed for the laptop. So now let's take a look at the control portion of the configuration for our cluster. We're going to go into admin mode here, and as you can see here, all we have to do is specify the NV edge control and specify the serial number of which chassis is going to be which rack. Next, we're going to look at the data portion of the configuration here. So what we're doing is we're looking at the interface 0319, which I configured as an edge, and I also configured on rack 1 0319 as well. There are three other ports that has the same configuration. So now let's take a look at all four of those links. So you can see here port 19 of rack 0 is connected to port 19 of rack 1 and 20 is 20 and so on. So we're going to start this demonstration here by plugging in my laptop so we can generate the IPOE session here. So you can see here we got our address of 200.2.0.2. So go ahead and let's start up our video streams now. And we're going to our server, which is 192.168.100.2. And there's our video stream coming in right now. We're going to make some adjustment here and the video looks great. Okay, well, we have this video in the corner now. Let's take a look at our subscriber on the BNG router. So you can see here the BNG router shows the address 200.2.0.2, which matches the address that we were assigned. So next, let's look at the traffic going through the bundle interface. So on the outgoing side of the interface, we have bundle Ethernet 100. So you can see it has two member links from rack 0, 300 and also rack 1, 300. So if we look at the data on rack 1, 0300, we can see we're pushing right now 200 and some odd packets. Okay, if we look at on rack 1, we see we're pushing no packets through that because right now we're only running a single stream. So now let's take a look at the incoming side interface, which is bundle Ethernet 200. And you can see it has member links 0305 and 1305. And if we look at the data rate on 0305, you can see that its incoming rate is 225, which matches the outgoing rate we saw earlier. And then on the rack 1 side, we have also 0 packets going into the router. So here we're sending video data from the server to the top link to rack 0 and then out of rack 0 and then eventually to the PC. So next we're going to shut down the top left link and the bottom right link. And what that will do is that will force the traffic to go to rack 0 via the top link, through the cluster link in the middle, and then down the bottom left link, and then eventually to the laptop. Now remember here that there are no routing protocols between these two routers. Basically, these two routers are acting as a single router. In other words, these two routers are behaving inside of a cluster as a single router. So we're going to go ahead and shut down interface 0300 and 0305. Sorry, 1305. And we're going to go ahead and commit that. You can see here once it's committed, you don't see any problems on the video. The video is still going nice and smooth, no hiccups or whatsoever. And now let's look at the data rate between the two interfaces. So you can see here 00, it's actually coming down, so because it's a 30-second average. So you can see that packet number is coming down because the packets are no longer flowing through that interface. Okay, let's take a look at the 1300 now. You can see this is the other packet that's coming up now, and you can see the packet rates are increasing on this interface now. And let's take a look at 0305, and you can see packets are flowing on this interface on the incoming side, just as before. And on the other interface, 1305, we should still have 0 packets flowing in. And there you go. Next, we're going to do two failover types of demonstrations here. One is going to be a route processor failover. So we're going to fail the active route processor on one of the chassis, and so it goes over to the standby route processor. Next, we're going to go ahead and reload one of the routers in the cluster. We're going to pick the one that's listed as the DSC, or otherwise known as the designated shelf controller. We're picking this one because this is the node that is supposed to be in control or the master of this cluster. So here we're going to go ahead and go to admin mode, and we're going to do a redundancy switchover. So in other words, this is going to switch from the active RP to the standby RP for rack 0. Okay, so we've done it here, and now the active RP, which is the RP that we should be on right now, should be starting to reset. And you can see from the video itself, there seems to be no effect on the video itself. The video is still playing nice and smooth. We're going to wait a few seconds here, and then we're going to take a look at the other RP, which is going to be the standby RP that's coming up and becoming the active RP at this point. Okay, so now we're looking at the standby RP, which is coming up as the active RP. There it is. And we're just going to log in here. Okay, and we're going to do a show platform just to kind of verify that the other RP is still in fact in booting state. And there it is, and with no effect to the video at all. It might be interesting to note that the DSC function was on rack 0, but since we lost one of the RPs in this case, that DSC functionality has now moved to rack 1. And you can see the message here that indicates that. Okay, let's do a quick check to make sure the standby RP is back up and it's ready. Okay, looks like everything is good. So now we're going to go into admin mode here and then check on the DSC. Okay, so you can see here under the role you have a standby and active. That just means the active or standby RP role. Okay, what's more important on the right side where it says state, it says primary DSC and backup DSC. As you can see here, rack 1 RSP 0 is the primary DSC. So what we're going to do is we're going to go ahead and reload rack 1 in this case. So we're issuing this reload command from rack 0, just so you're aware. So we're going to go ahead and confirm the reload of rack 1, and there it is. Okay, you should see a few messages about the control link coming down. Now if you recall, these are the links that are connected between the RSPs together in the cluster. So you can see the other chassis got reset and the video still looks great. Router's up and ready. Here's a quick look at the two RSPs, and you see they're both in reset state for rack 1. Now we're going to switch back over to the active RP of rack 0. And you can see here, no problems on the video. Let's do a quick check on the subscriber. Okay, and you can see that we're still up, and there's no problem there. The subscriber, it still shows up in the router itself. Okay, and let's go ahead and take a quick look at the bundle interface, and we should see only one link member for the bundle interface because the other chassis has gone down. And there it is, one link, and the system's still up and running without any problems.